Hello, my dear students. Welcome to one more amazing session from Sri Chaitanya Academy NEET White channel. So today we are going to discuss about the CBSE series. In that we'll discuss solutions and colligative properties. Are you ready to take 8 marks in your pocket right now in today's class? In 1 hour I am going to make a total revision of the solutions and colligative properties. So in this series we are going to see how to score the best in the chemistry examination. Before going for any examination, you need to have a particular plan. Today, I will give you the plan to make the chemistry awesome and the most scoring subject. Are you ready with us? So, those who are online, please like the session and just subscribe to this channel so that we can do the best of the CBSE chemistry. So, out of 70 marks, 8 marks is coming from solutions. Hi Sunit, how are you? And from these solutions, what are the subtopics are there? By this time, you completed your preparation and maybe half completed or maybe having some doubts. Let it be. I am here to unveil everything. Use short box and tell whatever your doubts. I am going to unveil all the things. Okay, students, in this session I will give you the best plan out of it. Okay, so very important theory based questions. So आज हम चर्चा करने वाले प्लान कैसे बनाना एंड चैप्टर में हर टॉपिक का इम्पोर्टेंस क्या है and how to go ahead with the preparation and short recapture about the concepts, and at the end some PYQs also I will give you, right beta? In this very important theory questions, define colligative properties, okay, state Raoult law. For volatile solution and non-volatile solutes, why are colligative properties independent of the nature of the solute? And it depends on the number and the count as well. And also what are relative lowering of vapor pressure and mathematical expressions be here? Very important. RH is a define osmotic pressures and Y is considered to be most reliable colligative property. I want to say here, if you want to measure the molecular mass of a protein or a polymer, you use the osmotic pressure method. So why so? So like these questions you can get it. Reasoning questions are very, very important in the CBSE pattern. So I want to say, when you write the CBSE examination, so you're writing the answer, let the answer at the end of the numerical, maybe little error is there, but you will be given total marks based on the approach, based on the way you presented, based on the units you made it, and everything does matter. So you can frame your own words and you can write the examination, right bacho? And you can see various things, what are azeotropic mixtures, and define Van't Hoff Factor for association and dissociation. So what happens, colligative properties when it is associated or dissociated, everything is important. And also you focus on the numericals. So numericals will come from chemistry part 1 textbook, solutions and colligative properties, and electrochemistry and chemical kinetics. ये सिर्फ ये तीनों चैप्टर से आपको न्यूमेरिकल्स आने को संभावना है. And you don't have to worry, in today's class I will tell you how to approach the numerical as well. Okay, anyways, in the board's favorite, 100% you're going to get from the numericals bacho. So you can get the colligative properties, Raoult law, and elevation of boiling point and depression and freezing point, and osmotic pressures, and sometimes Henry's law constant based on that. And you have to tag Van't Hoff Factor in order to calculate the molecular mass. It could be for association or it could be dissociation. So it's a short recapture because this is not a lengthy session and we will discuss everything in a short recapture. So what is the outcome of today's session? Simply you can say, when you just attend every day, my class will be there in the same day, every day one topic beta, and whatever you prepared so far, and I make you to revise, I will revise it. You just watch the session and you will get the best out of it, right bacho? So let us see, and calculate the osmotic pressure of the solution. The given temperature is the normal simple numerical you will get it, and determine the molarity, molality, mole fraction of the solution, every common short numerical, okay. You never wonder if you get a question directly from the NCERT bachcho. That is very important. Compare the boiling points and the freezing points, which is increasing and which is decreasing, and multiple choice questions are also there in CBSE. As you know, assertion reasoning, and 4 options will be there, 1 option is correct, like that you will do it. And let us see, the point number 1 is going to be concentration terms. These many concentration terms are there, so to measure the strength of the solution, various concentration terms are there. So strength, molarity, normality, weight percentage, volume percentage, and also you can see molality, mole fraction, and ppm, and W by W percentage. Among all, so a common question is there from the CBSE, which is dependent and which is independent. All volume dependent concentration terms are dependent on temperature, right? And I want to say which is independent. So which is independent? Mole fraction is independent, and molality is independent, and W by W is independent. So when you check the multiple choice question, you just find anything here is going to be temperature independent, rest all temperature dependent, right? So let us see simple definition wise how to calculate, and definitions are important. You have to write, when you write the answer in the CBSE examination, write in a crystal clear, crisp and short answer straight away. You may increase the length of the answer when you attempt the long answer questions, okay. For very short answer questions and short answer questions, you be confined to the limited amount of the text, because paper correct करने वालों के भी थोड़ा आसानी होगा, and you write in a simplified version, right? And बच्चों weight percentage, weight in grams of solute present in 100 grams of solution is called weight percentage. That is the weight of solute by weight of solution into 100, okay. It is W by W you can say. और एक चीज है weight by volume. So that is the weight of a solution present in 100 milliliters of solution is called as a W by V. So the term itself indicates what is it, okay. And also you can see W by W, V by V. So the volume in milliliters of solute present in 100 milliliters of solution. So it is exclusively used for both liquid, solute and solvent or liquids, right? And coming to the molarity, I don't want to give such a big explanation for everything. Molarity, it is the number of moles of solute present in a liter of solution, right? That is what is called as a molarity. It is indicated with M, and molarity is equal to number of moles upon volume expressed in liters. So that mole liter inverse is the dimension for this molarity, right? So we'll see wherever you use the formula, wherever you use the numerical, write its dimension. CBSE का हिसाब से you have to use the units. So otherwise maybe half marks you can lose it, okay. Now moving ahead, it is the number of moles of solute present in the liter of solution, and also W by gram molecular weight, weight of the solute, gram molecular weight into 1000, we expressed in milliliters, right? So this is the formula. We use this formula for several times, okay. And those students, if you have any doubts, please let me know, right? And various relations that you can say. And in my class something special should be there. If you say a solution, a question is given, a molar solution, mean to say its molarity is 1. A semi-molar solution, it says that molarity is 0.5. A decimolar solution, it indicates that molarity is 0.1. Okay, like that, A तीनों comfortable है. and you need not have to go like that, just use the prefixes. It's a common usage, right? And also some useful relations that you can see in solutions and colligative properties. So number of moles, so molarity is equal to number of moles upon volume. So number of moles is molarity into volume, fine. And also number of moles of solute present in V milliliters, that is mv by 1000. आज का जो session है ना, if you are just confined to the context here, and you can write your NEET examination and whatever the competitive examination it is there, right? Come on. So let's see here, number of moles of solute present in V liters of solution is mv, as I mentioned here. And also when a solution is diluted, the volume of the solution may increase or decrease, but number of moles is going to be constant. So mv is going to be constant. So that on dilution, bacho, m1 v1 is equal to m2 v2, m1 v1 before dilution, m2 v2 after dilution, right? And also you see molarity, weight by gram molecular weight into 1000 by V in milliliters, expressed in milliliters. That's very, very important, bacho, right? Very good. So I want to see those who are online, just give me a thumbs up and fire emoji so that the session goes with a lot of fire, bacho. And the weight volume percentage is given. So shortcut देना चाहता हूँ, कभी कभी ये weight volume percentage देता हूँ and molarity निकालने की कोशिश करता हूँ. Molarity is equal to 10 into weight volume percentage upon gram molecular weight. If specific gravity is given, क्या करूँ मैं? Yes, 10 into specific gravity into weight percentage upon gram molecular weight. अरे specific gravity का मतलब you can take a density into the consideration. Density into the consideration. So molarity is equal to 10 into density into weight percentage upon 1000. That is a very important shortcut formula. You just follow this. And you see a mixture, when two solutions are mixed, let us say here m1 v1 is there, another solution whose m2 v2 is there, and you get the mixture. So the molarity of the mixture is going to be m1 v1 plus m2 v2 upon v1 plus v2, right? And you can see the molality now. So we'll go just like a quick recapture about the total solutions of colligative properties. So what is the molality? So it is the number of moles of a solute present in a kg of the solvent, and molarity you take a liter of a solution, here you are going to take a kg of a solvent, right? So solvent you have to take, and the same thing, mole liter inverse is the unit for molarity, and mole kg inverse is the unit for molality. And when you see molality is equal to weight of the solute upon gram molecular weight into 1000 by weight of the solute in grams. So this is very, very important, and it is an accurate and convenient method because it is based on expression concentration independent on temperature. That is the reason why molality is preferred over molarity, since it is temperature independent. So another one is going to be your favorite, mole fraction. Whenever you talk about Vapour pressure and Raoult law, you talk about the mole fraction only. What is a mole fraction? It is the ratio of the number of moles of a component to the total number of the components present in the solution. So if it is a mole fraction of A is going to be Na upon Na plus Nb. Similarly, mole fraction of B is equal to Na, okay, Na upon Nb upon mole fraction of B. I want to say mole fraction of B, mole fraction of given like this. And what if mole fraction of A plus mole fraction of B is summed up? You are going to take a unity. Sum of the mole fractions of all components is going to be 1. Fine. Any doubts, bacho? Any doubt? Fine. Now some useful relations better. These are the some useful relations. Take a screenshot everybody. 3, 2, 1. Click it. That's good. So molarity. Molality is equal to 10 into solubility by gram molecular weight. Solubility, you take a gram of solute present in 100 grams of the solvent. Okay. And molality का जो relation होता है ना, that is also very important. Molality is equal to 1000 into molarity upon 1000 into density minus molecular mass into mass of the solvent into gram molecular weight. So mole fraction of the solute and molality, okay, that is also very important. That is given molality upon molality plus 1000 by molecular weight of the solvent. So factors, what is the solubility? The maximum amount of the solute that can be dissolved in a liter of solution is called solubility. So factors affecting solubility is very important. I don't want to indulge into the details of this, but I'll give you the outlines. Nature of the solvent and the solute. Ionic compounds are more soluble in polar solvents like water, and the vice versa, you can say. Temperature of the system. It depends upon whether the process is endothermic process and exothermic process. I'll tell you here. If a solid is dissolved in a liquid, in most of the cases, it is going to be temperature increased and the solubility increased. If it is a gas, as temperature increases, solubility decreases. That's important, okay? And pressure of the system. If the solute is a solid, has no effect, but the solute is a gas, pressure has a super impact on the dissolution process. Henry's law का हिसाब से बोल सकता हूँ. Now you see here nature of the solute and solvent, and higher the intermolecular forces between the solute and the solvent, it is going to be the more is the solubility, and it is given as ammonia is more soluble in water than carbon dioxide, because ammonia is the one which forms intermolecular force with water by means of hydrogen bonding. Right? But carbon dioxide do not form hydrogen bonding, isn't it? So सिर्फ dipole-dipole interaction चलता है. Fine. And also you see temperature. So based on the nature of the dissolution, temperature of the system, if the process is endothermic, so delta H होगा आपका पॉजिटिव होगा. ली चार्टलियर प्रिंसिपल के हिसाब से अगर टेम्परेचर बढ़ते जाते हैं, सॉल्युबिलिटी भी बढ़ते जाते हैं. And if it is an exothermic, delta H is going to be negative. So what happens as temperature increases, solubility decreases. Are you getting or not? So this is the crystal clear way you need to have something in your mind and you prepare like this. बच्चों समझ में आ रहे क्या? अगर कुछ डाउट है ना तो चार्ट बॉक्स यू आप एनी क्वेश्चन यू कैन आस्क. ठीक है बेटा? Now let us directly jump into the solubility of carbon dioxide in the water. So I want to take carbonated water, आपके सोडा है, put in the cold water. What happen? So temperature बहुत कम है, solubility okay, and if I take in the hot water, so what happened? Temperature increases, solubility decreases. You see the gas is coming out. So as temperature increases, solubility decreases. Are you getting or not? Now I want to say gas is in equilibrium with liquid solution. If this is a liquid, this is a liquid, and this is a gas. So what happened? When you apply pressure, no, you are going to increase the movable frictionless piston. So the gas is going to move into the solution. I want to say as pressure increases, solubility of a gas in the liquid increases, that is given as Henry's law. So, gas in equilibrium with the liquid solution, rate of dissolution of a gas is equal to rate of escape of the gas at a liquid equilibrium happens. That is at equilibrium what happen? If you increase the pressure, if pressure increases, the equilibrium get disturbed. So, more gas molecule escape into the solution phase and restore the equilibrium. So, I mean to say the solubility of the gas increases with the pressure. So, solubility of gas is directly proportional to pressure of the gas. So, as long as the temperature is constant, this is Henry's law, and the solubility of a gas in a liquid at a given temperature is directly proportional to the partial pressure of the gas present above the solution. This is the partial pressure of the gas, right? Let us just push down, more gas is going to be incorporated into the liquid, that I want to say. So, Henry's law एक ही formula है, pressure of the gas is equal to Henry's law constant and mole fraction of the gas in the liquid, right? And this is Henry's law constant, इसका हिसाब से कुछ क्वेश्चंस आने का संभावना है बच्चों. Fine, any doubts? Let us discuss some previous year CBSE questions as well. And if you see, pressure of the gas is directly proportional to Henry's law constant and mole fraction of the gas. So, pressure of the gas, mole fraction is going to be a straight line, slope is going to be Henry's law constant. Fine. And so, very good graphs and very good animations I am making you, okay. But you can see characteristics of Henry's law constant. You need to have a clarity before you enter into the examination. Tomorrow is my English paper board, Maharashtra. All the best. Anuj, all the best. Enjoy the class right now. And same unit as that of pressure, right? It has the same unit as that of pressure. And different for different gas liquid system. And KH increases with temperature. Different gases will have different KH values. KH depends on intermolecular forces of the gas liquid system. And KH value decreases with increase in the solubility. So, these are the characteristics of Henry's law constant. So, everybody knows this pressure of the gas is equal to KH, the mole fraction of the gas. Everybody use this. You do lot of hard work and you do lot of numericals based on Henry's law constant, but these are the crystal clear picture you need to have before the examination. Okay, I am telling you, more objective level questions are coming. More objective level questions are coming in CBSE. So, you need to be focused there. Now, bacho, you can see limitations of Henry's law. Now, Henry's law is only valid under the conditions. So, pressure of the gas is not too high and not too low. And also temperature is not too low or high, and it should be, temperature should be constant. Okay. And gas should not have any chemical reaction with the solvent. You want to dissolve ammonia in the water, okay, so you don't use Henry's law constant. Ionization bhi ho sakta hai na. And gas should not undergo any reaction with the solvent, and dissociation or association jo bhi hai. Fine, right. Now, something I want to show you about the vapor pressure. So, what is vapor pressure? When the liquid is evaporating, again vapor is liquefying. So, this process is called evaporation and this process is called condensation. So, there is a situation called equilibrium, and at the equilibrium you can see, at the equilibrium, bacho, you are going to see this liquid vapor is heating on the surface of the liquid and causes some pressure. and that pressure is called as equilibrium vapor pressure, or simply vapor pressure you can call it. And this is the vapor pressure decides everything, any colligative property. Okay, and let us talk about effect of temperature on the vapor pressure. So the vapor pressure depends on nature of the liquid and the temperature. What happen, as it's a lower temperature, the kinetic energy this much. According to kinetic molecular theory, kinetic energy is directly proportional to absolute temperature. As temperature increases, okay, kinetic energy increases. As a kinetic energy increases, what will happen? Vapor pressure increases. Vapor pressure increases. That is very, very important. So, getting all the concept in one shot. Well, now moving ahead. So, effect of temperature, it is given by Clausius-Clapeyron equation, ln P2 upon P1 delta H by R of 1 by T1 minus 1 by T2. So, delta H is equal to enthalpy of evaporation, and P1 is the vapor pressure at a temperature T1, and P2 is the vapor pressure temperature T2. And you just memorize this equation, and mostly you may not get a numerical based on this, because we have the derivatives of this in Arrhenius equation, chemical kinetics. Fine, beta. This is very, very important. Never lose it. And moving ahead, Raoult's law. So you see the Raoult's law. When you mix two liquids and the partial vapor pressure of a liquid is directly proportional to its mole fraction, right? So this is how liquid A, and this is how liquid B, and this is liquid AB mixture solution is formed. So that is what I want to say. Partial pressure, you can say partial pressure of this, right? And partial pressure of this B, and this is a PS is equal to P naught A mole fraction of A plus P naught B mole fraction of B. That's एक ही formula है, सिर्फ एक ही formula है. You just visualize it and you will understand this A and this B as the mole fraction of something is increased, its vapor pressure is increased. So let's see. Solution containing a volatile solute and a non-volatile solute. So let's talk about the volatile solute. So XA is a mole fraction of A, and XB is a mole fraction of B, and P naught A vapor pressure of the pure liquid A, and P naught B is the mole fraction of pure liquid B. And how these are related, I just showed you here. PA is directly proportional to mole fraction of A, and PA is equal to P naught A mole fraction of A. You see, the P naught A is always constant, whatsoever the condition may be. Similarly, PB is directly proportional to mole fraction of B, and PB is equal to P naught B mole fraction of B. And when these mix together, na, PS, solution vapor pressure is equal to PA plus PB. PA plus PB, isn't it? That's what it is given as. If you talk about the vapor pressure and mole fraction, you are going to get a straight line, because PA is directly proportional to mole fraction of A. You can say it is a PA, and you can say it is a mole fraction of A. It is going to be a straight line. Slope is going to be tan theta, gives rise to P naught. Fine. That's good. Let us talk about vapor pressure of P and mole fraction of. You are going to get a straight line. And let us talk about B. I want to write the graph in this way, as mole fraction of B increases and vapor pressure also increases, isn't it? and these two, it was A and it is B. These two are incorporated in the same graph, you are going to get like this. So this is what is called a PA, and this is what is called a PB, and this is what is called a PS or P total, PS or P total, right? And let us talk about the ideal solution. What is this ideal solution? So when binary liquid solution, P total is equal to PA plus PB, right? So I mean to say P total is equal to P naught A mole fraction of A plus P naught B mole fraction of B, right? And vapor pressure and mole fraction in the vapor state, that is given as vapor pressure. Questions are there in the CBSE textbook, NCERT, whatever the board you are talking about, it is given as, I want to say vapor pressure mole fraction of A is equal to YA P total and P naught A. Okay, I want to say mole fraction of A in the vapor state is equal to PA upon P total. Simple. You can do it from here. Similarly PB, right? And moving ahead, what is an ideal solution? Ideal solution is a solution which obey Raoult law at all conditions. That is called as ideal solution. In the ideal solution, the only one game is intermolecular forces. The intermolecular forces before mixing is equal to after mixing. Solvent-solute interaction is equal to the solvent-solvent and solute-solute interactions. So I mean to say the magnitude of the intermolecular force before mixing is equal to after mixing. So for that, enthalpy of mixing is going to be 0. For that, enthalpy change, volume change is going to be 0. That is the criteria for the ideal solution. Bacho, here you can say entropy of the mixing is always greater than 0 and it is a spontaneous process, so that it is delta G is going to be negative. Right, bacho? So tomorrow is your board examination. All the best. Now let us see here example N-heptane and N-hexane. You can also say benzene and toluene. You can also say benzene and toluene. So like that you can see ideal solution, the solution which obey Raoult law at all conditions, so that it obeys this graph as well. So this is the graph for the ideal solution. You have non-ideal solutions. So the graph should come the deviation. You are back. Hi Pandit, Surya Pandit. Oh, we are not talking nowadays. Yeah. You are. Then why you are not talking? So if it is a non-ideal solution, the graph should come down like this, negative deviation. If the graph comes like this, positive deviation. So above the line and below the line. Asta, Aryan, very good. Now let us talk about non-ideal solution. A solution which do not obey Raoult law at all conditions is said to be a non-ideal solution. That's good. And that non-ideal solution is of two types. It could be a positive deviation and it is a negative deviation. A positive deviation hota hai kya? So I just want to give you the difference between here the positive deviation and the negative deviation here. So wonderful presentations are given. So the positive deviation, solvent-solute interaction is less than that of solvent-solvent and solute-solute interactions. Intermolecular forces is decreased when you add two liquids. Okay, when you see solvent-solvent interaction is more than that of these solute solvent interaction, so that intermolecular forces बढ़ते जाते हैं, so vapor pressure decreases, so negative deviation में vapor pressure decreases and positive deviation में vapor pressure increases, okay, and delta H mix is greater than 0 and delta H mix is going to be less than 0, okay, and V mix is greater than 0, V mix is going to be less than 0. Delta H is greater than 0, heat enter into the system, heat released out of the system, right? And you can say here colligative properties. Now we are in the colligative properties. Those properties which independent of the nature of the solute but dependent on the number of solute particles are said to be colligative properties. You have relative lowering of vapor pressure, elevation in boiling point, depression in freezing point, and osmotic pressure, isn't it? So let's discuss carefully about this elevation of boiling point. When you add some non-volatile solute to the solution, so the vapor pressure is going to be decreased relative to that. So I want to say the relative lowering of vapor pressure is given as P naught, yeah, I want to say here for the non-volatile solution, yeah, it is going to be P naught minus Ps upon P naught is equal to mole fraction of the solute. B is the solute. So this is very important. A is a solvent and B is a solute. So decrease the vapor pressure, so that delta P upon P naught A is equal to NB upon NA plus NB, and you can ignore this because this value for a dilute solution is very less. So P naught minus Ps minus P naught is equal to NB by NA. You can calculate molecular mass from this, and you can alternative formula, you can say P naught minus Ps upon P naught is equal to NB upon NA. So just उल्टा करके थोड़ा derive करके देना चाहता हूँ. Whenever you want to calculate the molecular mass, you use this formula, and this can be used for both dilute solution, very dilute solution, whatever the condition. So it is P naught minus Ps upon Ps is equal to NB upon Na. Any doubt? This is super important. Only one thing I want to say here, whenever you want to calculate the molecular mass of the solute, you can directly use this. And also elevation in boiling point. So water boils at exactly 100 degrees centigrade. You add some salt in that. Now it becomes a solution. So what happened here? The water boils at more than 100 degrees centigrade. That is called elevation of boiling point, right? Now, what is a boiling point? The temperature at which the vapor pressure is equal to atmospheric pressure. That is what is called as a boiling point temperature. So vapor pressure and external pressure. So then only you are going to get kind of bubbling in that. So let us say elevation in boiling point. Vapor pressure and temperature, no? When that you just see here, yeah, vapor pressure, if it is, yeah, it is showing here, pure solvent and the solution, and the temperature 1 atm jab aayega na, that is the temperature of the solvent and this is the temperature of the solution, and the temperature difference here it is called as the elevation or increase in the vapor pressure. The increase in the vapor pressure is directly proportional to the molality, and delta TB is equal to Kb into molality. That's it. Kb is called ebullioscopic constant or molar elevation constant. That is given in the slide in this way. So m is molality. So let's talk about what is a Kb here. Kb is what is called molar elevation constant or ebullioscopic constant. समझ में आ रही क्या आर्यन? Right. So now let's see. Kb is thermodynamically determined RTBm into delta H into 1000. R is a gas constant, Tb is the boiling point of the solvent, and m is the molecular mass of the solvent, and delta H is equal to enthalpy of evaporation of this particular solvent. And this is a definitions. Kb is defined as, so as delta Tb is equal to Kb is equal to into molality. So if molality is 1 mole Kg inverse, then Kb is equal to delta Tb. So based on this definition based questions, you will be asking definition of this molar boiling point constant. So the molar boiling point constant is defined as the boiling point elevation for a solution made by 1 mole of a solute is dissolved in a kg of solvent, right? Otherwise, the molar elevation constant observed for 1 molar solution. And I want to say here depression in freezing point. Depression in freezing point. So now we are running like, so I don't want to take 3-4 hour session. In next 15 minutes we will complete the session, right? So let us see here the depression in freezing point on addition of non-volatile solution of a pure liquid. I want to say water freezes at 0 degree centigrade. If you add some salt to that, what happens? Water is going to freeze at -2, -3, something like that. Okay. So the freezing point is decreased. The freezing point of solution becomes lower than that of a pure liquid. That is what is called as a freezing point depression. So I mean to say freezing point is reduced, right? That's good. But you can see here the depression in freezing point T not F, freezing point of a pure liquid, and Tf is the freezing point of the solution, and depression in freezing point is equal to T naught F minus T naught Tf. So this is directly proportional to again molality. Again molality you can say. I mean to say delta Tf is directly proportional to molality. Delta Tf is equal to Kf into molality. Okay, Kf into molality. And that Kf is called cryoscopic constant. Cryoscopic constant. Molar depression constant. Are you getting or not? Everybody. Depression constant. Let us see how it is defined. And water, 1 molar sugar, and you can see here, yes, nice videos that are made for you to better understanding. So if you increase the temperature is 0, if you add some solute in it, you are going to freeze. A solution is formed here, and it is self-explanatory, right? And if it is B, it is minus 1.86. And the solution C, and it is freezing, and minus 3.7, right? So different solutions are shown here, and ABC 0 degree centigrade, minus 1.86, minus 3.72. If the solute has 1 molar concentration. Now I want to say here it is one more important thing, osmosis. What is the meaning of an osmosis? Definition is very important. So, a spontaneous flow of solvent particles from the solvent to solute side from higher concentration to lower concentration. So, it is a semi-permeable membrane. It is a low concentration. It is a high concentration. Solvent migrate from the low concentration to high concentration across the SPM, that is called semi-permeable membrane. This is a spontaneous process, and this process is called osmosis, and this is through a semi-permeable membrane SPM. What is this SPM? So let's talk about what is SPM. Semi-permeable membrane, a membrane which allows only solvent particles through it but not solute. Any animal membrane is an example for that. Animal membrane is an example for that. Okay. And copper ferrocyanide is also an artificial semi-permeable membrane. Okay. CuFeCN6. This is artificial semi-permeable membrane substance. Okay. Now, see here. When a semi-permeable membrane is there, it is a low concentration and it is a high concentration. It is high concentration and it is a low concentration. So that what happens, solvent is going to migrate from low concentration to high concentration, so that it reached up to here, from here. So osmotic pressure is given as HdG. H is the height of this column and D is the density of the solution and G is acceleration due to gravity, right? And how do you use this formula in calculating osmotic pressure? Osmosis is a process and osmotic pressure is a colligative property. Osmotic pressure is a colligative property, osmosis is not a colligative property. Bacho, here you can see, so osmosis pressure when the solution one and it is a solvent. Generally, you see, generally the solvent migrate from here to here. This is a normal osmosis. But what happens now? Okay. SPM, high concentration, and it is a low concentration solvent, generally migrates like this. And if you apply pressure here, when you apply pressure here, okay, solvents start moving from high concentration to low concentration. Samrat, everybody is watching. For one student is also, I am going to take care of this. You just, this is called reverse osmosis. This is what is called as a reverse osmosis. I know this is a board's time. Students' time is also very important. So we want to do from the Sri Chaitanya Academy YouTube channel, we want to do the best out of everything, right? Now, so this is what is happened when a solvent to a solution, this is a normal osmosis, right? When you apply pressure from here, external pressure is applied. Okay, external pressure is applied. What will happen? You are going to see the solvent start moving from the solution to the solvent. So, condition for the reverse osmosis, condition for the reverse osmosis is the external pressure is greater than osmotic pressure. Then that is how the desalination of water takes place, reverse osmosis का process है. And how to calculate osmotic pressure? Pi is equal to CRT. You are with me? Then find those who are online, please like the session and encourage with me. So pi is equal to CRT. C is the concentration and R is the gas constant, and generally you use 0.081 liter atmosphere mole inverse and Kelvin inverse. So this is the way you have to use, because T is the absolute temperature. And so you have various types of solutions. Osmotic pressure, pi is equal to CRT, we just had this, okay. Anyways, osmotic, it is copied multiple types, types of solutions. Hypotonic solution, isotonic solution and hypertonic solution. Isotonic solution, pressure, osmotic pressure of the solution is equal to the cell. Hypertonic solution, osmotic pressure of the cell fluid is greater than the solution and it is less than that. So I want to say here, the solution having lower osmotic pressure, the solution having higher osmotic pressure. So the solution of us, right? And if you keep this hypertonic solution, if you keep a RBC in various solutions, you are going to see that is yeah, right. You can see here. So hypotonic solution, isotonic solution, hypertonic solution. When the cell is placed here in the hypertonic solution, the cell is going to be shrinked, while in hypotonic solution the cell is going to be bulged. So like that you can see the various combinations of this, okay. And abnormal colligative properties. So if we look at this, colligative properties are dependent only on the number of solute particles. But what happened, due to association or dissociation, number of solute particles are going to be changed. So to correct colligative properties, multiply colligative properties with I, which is called as a Van't Hoff correction. What is this actual Van't Hoff correction? So dissociation of a solute. So it is the number of molecules actual upon number of molecules expected. The ratio is going to be Van't Hoff factor. And say an example, KCl is dissociating, gives us K plus and Cl minus, right. So it is going to give you 2 moles of this of particles and 1 mole of the KCl to gives us Van't Hoff factor 2 if it is 100%. But the thing is here, if it is a dissociating, what happens? Association. So the molecules are going to join together, like acetic acid in benzene, CH3, C double bond O, OH, and CH3 and C double bond O, OH. So there is a hydrogen bonding, because of the hydrogen bonding, the number of particles are decreasing. So as the number of particles decreases, you see, I is less than 1, I is 1 means it is going to be a non-electrolyte. If it is a greater than 1, it is an electrolyte, it is less than 1, it is going to be association. So you have to correct by using this Van't Hoff factor. And let us see this Van't Hoff factor, and it is the ratio of the number of particles after association or dissociation to that number of moles dissolved in it. I am talking about the solute, right. So after correction, this Van't Hoff factor, this is going to be, for electrolyte it is not equal to 1, for non-electrolyte it is going to be 1. So in CBSE examination, whatever examination, glucose, sucrose and urea, So these are the kind of solutes that are said to be non-electrolytes. And if it is association less than 1, if it is a dissociation greater than 1, right? And so if it is 100% dissociated, what is the situation? NaCl, it is going to give Na plus and Cl minus. So yeah, I is equal to 2. Urea, I is equal to 1 non-electrolyte now, and Al to SO4 thrice, 2Al3 plus and 3SO4 2 minus. So I is equal to 5. So like that, sodium hydroxide, again I is equal to 2. Fine. So colligative properties after completion of this correction, relative lowering of vapor pressure is equal to I into mole fraction of the solute. Elevation in boiling point is equal to I into Kb into molality. The depression in freezing point is equal to I into Kf into molality. Pi is equal to ICRT, right? So what happened? Corrected colligative properties, you can say this correct colligative properties ka formula. And moving at degree of ionization, you see alpha is the degree of ionization for dissociation. Alpha is equal to I minus 1 by N minus 1. For association, it is going to be alpha is equal to I minus 1 by N minus 1. For dimerization, I is equal to 2. N is equal to 2. Trimerization, N is equal to 3. Tetramerization, N is equal to 4, like that. So we can see, I want to discuss some CBSE questions that we encountered in the previous years. Cooking is faster in pressure cooker than in open pan. So pressure cooker में क्या होगा? Pressure cooker में P external increases, boiling point increases. Okay, so that it takes less time to cook, and it is also very reasonable question. You can see, bachcho, on mixing X and Y, the volume of the resulting solution is decreased. Delta V is less than 0. Right? Delta V is less than 0. So that it is a negative deviation. It's showing that negative deviation. So what type of deviation from the Raoult law is shown by the resulting solution? It is showing a negative deviation. And what is the change in the temperature? Would you observe? So the change in the temperature is going to be delta V is less than 0 and delta H is going to be less than 0. So it is going to be endothermic process. So like that, and it is a super important question, What is an azeotrope and what type of azeotrope is formed by negative deviation from Raoult law? Given example. So azeotrope is the one which has a constant boiling mixture. Azeotrope is constant boiling mixture. The solution in a specified amounts they are mixed, they are going to boil together. So that is called as a constant boiling mixture or azeotropic mixture. And I'll give you a trick. Azeotropes are two types. Positive boiling and negative boiling. So the simple thing is, the azeotrope, positive boiling azeotrope means they boil more than that of the solvent. Negative boiling is less than that of the solvent temperature. And the example will come, any solution shows negative deviation from from Raoult law is going to be a negative deviation from Raoult law. So positive boiling azeotrope or minimum boiling azeotrope, you can say minimum boiling azeotrope, and maximum boiling azeotrope, and vice versa you can say. So here example, any solution which shows the positive deviation from Raoult law. Simple. Here it is showing that negative deviation from Raoult law. It is going, azeotrope is formed by negative deviation from Raoult law. So it should be positive deviation from Raoult law. It shows negative deviation, minimum boiling azeotrope. Okay. That's good. That's good. So, bachcho, as the time is exhausted, we'll see you tomorrow with electrochemistry, bachcho. So many questions are there. Tomorrow we'll get maximum doubts and maximum questions from the previous CBSE examination. So every day the class is going to be there, and I am going to cover all the chapters, and I will show you the best out of this. Okay, and stay tuned, and please like this session and share with your friends, and subscribe to Sri Chaitanya Academy NEET YT channel. Thank you. Signing off, Suresh, Faculty of Chemistry. Bye bye.